This is January 2010, question 6. A student carries out an experiment to find the speed of sound in air using a resonance tube. The experimental setup is shown in figure 6.1. A student sets a dial of the signal generator at 200 Hz and switches on the generator. Describe briefly the procedure which must be adopted by the student in order to obtain the first position of resonance. So of course what you have to do is move the whole thing up and down, but generally up a bit, until you can hear the loudest possible sound at the shortest length, and that's your position of resonance. So if you say then that you're going to move tube up until you hear the loudest sound. This is resonance. The shortest length at which this happens is measured then. Okay, so move the tube. You could check, you could write in there if you wanted to be more precise and make sure that you're definitely getting your marks. Check by repeating. Moving tube down the way. So you could bring it up a bit further and then push it down in again and check that you're getting that resonance at the same position. Part B, if the length of the air column for the first position of resonance is found to be 38 centimetres, calculate the speed of sound in air. So if I just draw this at the side, you're going to have this idea here in your air tube, and that length is equal to 1/4 of a wavelength. So therefore that means that if you know the length is 38 centimetres, then the wavelength is 4 times the length. And 4 times the length comes out to be 1.52 metres. I've changed it into metres. And then you just do V equals lambda F. You know F is 200. And that comes out as 304 metres per second. Explain why it would be good experimental practice for the student to repeat the experiment at other frequencies. Well, it's going to be more accurate. Because what you hear is very subjective to your hearing. It means, it's you deciding that it's the loudest sound. So loudest sound is subjective to a person's hearing. So if you repeat, then this will give you an average, and you're more likely to be accurate if you do that. To obtain a second frequency, the student adjusts the setting on the signal generator. Unfortunately, he adjusts the wrong dial on the signal generator and turns a dial which multiplies the frequency value by 10. Explain why this would make it difficult excuse me, to take a reading for the first position of resonance. Right, that means that he's turned it up to 2000 Hz instead of 200. And if we look at our equation, V equals lambda F, if we were getting that 304, if you were getting that 304 speed of sound, and you divide that by 2000 to get a wavelength, your wavelength will be coming out there at approximately 0.152 metres. But that means the length of your tube, remember the length is lambda over 4, is only 0.038 metres or 3.8 centimetres. And to try to measure this 3.8 centimetres accurately is going to be very difficult. because you'll only be using the very shortest end of the tube, and to get 3.8 you'd probably measure 3 or 4 there, and 4 isn't just going to be as accurate as 3.8, so that's where the difficulty lies.